Hello, everyone. I can hear myself. It's always a good sign. So welcome to Securing Cloud-Native Communication. I'm going to start by riffing on something Mitchell said at the beginning of the conference. He talked a lot about the enterprise sort of focuses with security and communications at the edge. We harden the perimeter. Now, he used a more friendly term, perhaps than I'm going to use, but a lot of folks say this is what we call Death Star security. You focus on making a really strong perimeter, but as we know from Star Wars, if a womp rat-sized hole is left, someone can get in and do a lot of damage. Yeah? I'm not saying focusing on the edge is bad. It's actually very good as part of a defense in depth strategy. But you also need to make sure your internal security is good as well. A strong front door is no good if you're kind of letting people in like through the side. And lastly, we have to make it easy to do the right thing. Yeah, I say this time and time again, but in particular with security, if you don't make it easy to do the right thing, people are going to bypass stuff. Yeah, we as engineers, we're kind of naturally, if we've got a challenge, we will do it any way we can. You know, who hasn't put the security groups to kind of enable all? Who hasn't disabled network ACLs sometimes? You know, we've all kind of done that thing. If you take away nothing else, these are the 5 most important things from the talk today. One is that security is everyone's responsibility. Whether you're ops, dev, QA, I don't really care. I think it's everyone's responsibility, including the business as well. We're bringing in a lot of cloud into our stack. All the good things like Kubernetes, like Nomad, but we've already seen this a few times at the conference, it's making our network infrastructure quite heterogeneous. There's a lot of things in the mix now. Defense in depth is super important, but bringing in more things makes it harder to implement. Yeah. Now, I'm not going to cover like security, say, scanning your applications, scanning infrastructure. I'm going to focus only on network communication because I've only got like 30 minutes today. But I will briefly touch on some of the things I think, or the industry thinks, that are really important with security. One key takeaway is mind the gaps. I've seen a bunch of people using great stuff in Console, using great stuff in things like Ambassador, Nginx, using things like CDNs, but leaving subtle gaps in the security. If you're trying to do TLS from end user right the way through to service, there's quite a few points where you might terminate TLS and reestablish it. And it's very easy with different people owning different bits of the stack. So ops owning the CDN, say dev owning the service mesh, it's very easy to have gaps if you're not careful. And lastly, say it again, all security must have good user experience, good developer experience. I'm a massive fan of the HashiCorp stack for this reason. I think the UX of things like Terraform, Console, make it super easy to do the right thing, and we need to really kind of remind everyone in the team about this kind of thing. I'm the one on the right there. I've got to shout out my colleague there, my friend Nick as well. But I'm a product architect at Datawire. And as we are a small company, that basically means I do everything from pre-sales, solution architecture, dev advocacy. My background is very much Java developer. I moved into ops about 5 years ago. I actually met Nick at a company called Not on High Street in the UK. We were both working there, bringing in Console, bringing in Terraform into the stack. And I've remained friends with Nick since, and he helped me put this talk together. We actually did it at KubeCon, or an early version at KubeCon in Barcelona recently. Most of the code snippets you see today are actually from Nick, so massive hat tip to Nick. I'm going to put out some extra code next week as well, which stay tuned for that. But shout out, even though Nick's not on the stage, massive shout out to him. I'll start by saying security is everyone's responsibility. Now, as Nick and I were going through preparing this talk, we found some quite scary numbers. I'll share the sources with you in just a minute, but we found that 214 records containing personal data are exploited every second. The average cost of a breach is around $4 million US. If you're leveling up to breaching like 50 million records, the cost goes crazy, yeah? And this will be a game-changing event in your company. And these things are real. Just this morning, and I know Stefan mentioned this in his talk, but just this morning I got an email from the Financial Times saying that BA are going to be fined, hopefully, if they get it working, up to 183 million in terms of GDPR. Yeah? And in Europe, and I can still say that, I'm British, but I can still say I'm in Europe at the moment. This is a real thing, yeah? And even in the US, even in other countries, people are modeling things like GDPR. It is becoming serious. Privacy, security, becoming serious. Governments will issue fines, and this can be a business-ending moment if we're not careful. And it's only on the increase, these kind of attacks. couple of years old data now, but 72% year-on-year increase. I think I read somewhere that cyber security or cyber criminality is bigger business than the drug trade now, the international drug trade, because it's so much easier to get involved in cybercrime, so much harder to get caught than it is if you're drug running. Yeah? So don't quote me exactly on that stat, well worth a look, but people are after our stuff. State actors right down through to opportunists are looking to hack our systems. These are the references. If you do want to go in and have a look at these things, I thoroughly recommend you do. They're quite scary, to be honest, some of the stats here, but it's a good tool to convince the entirety of your business that security is really quite important. At Modernization, it's a gift and a curse, yeah? A lot of us, we've got our users accessing our systems, we're bringing in some Kubernetes, we're bringing in some Nomad, all this good stuff, but we've got these heritage systems, as I like to call them, yeah? Systems that make the money for us as a business. And the reality is, we've got to look after all this stuff. If you're an oldish business, you may even have things like mainframe, yeah? Or one classic example I saw under Bob or Jane's desk, they had like a really important database that had been left ticking away for several years, and we needed to network this into the stack as well, yeah? This makes it really hard to think about security. In terms of defense in depth, you really have to think at every level, whatever your role is in the organization. Some fantastic books there that I have learned so much from. In particular, Adam Shostat's book on threat modeling is like the gold standard of introducing security, thinking about security in your development workflow, in your delivery workflow. A couple other great references there as well. But you need things like think about things like hardening and scanning infrastructure. And also, very critically, because we often have polyglot stacks these days, is you need to scan your code, the dependencies, and the packaging, so containers or serverless or whatever. Shameless plug for a book I wrote last year with my buddy Abraham. If you're in the Java space, I wrote a whole chapter, basically, or we wrote a whole chapter focusing on how to literally scan everything from code to packages and with scanning dependencies along the way. This stuff is really not hard to do in modern build pipelines. I work a lot in Java, but I know all the other spaces, .NET, Go, Ruby. There is similar tools in there. We won't cover much of that today, but I'm going to be looking more, we're not really looking at encryption at rest, but encryption at rest is really important, but you also need to encrypt data in transit as well. And I'm going to be looking a little bit at principle of least privilege. This is really important in terms of authenticating users, but even now authenticating services. We're sort of breaking down our applications into many services, and we need to think what used to be, say, all in the monolith and everything could access everything. Now we've got the opportunity with microservices to be more restrictive on what can access what. Microservices aren't for everyone. They definitely introduced quite a bit of pain in my experience. Nick and I worked on an early microservice system together, but they do have a lot of advantages. And one of them is this ability to be able to kind of isolate different services in terms of security. So exploring end-to-end comms, you've got this kind of stack, or you're working towards this kind of stack, a hybrid of new world, old world. Consul is fantastic as a distributed key value store. I've been using it for many years doing this. It's a great service discovery mechanism as well. And it spans across all the things. I've used Consul template a bunch on VMs. The Kubernetes integration I'll talk a little bit more about in a minute. But that is first class. The Helm chart is fantastic for deploying Consul. Really easy to hook up all these things. You also need an edge gateway. Now, shameless plug, I work with Datawire. We created the open source Ambassador API gateway. There's many other gateways out there. But you really need your gateway to be talking, once the users are making a request, to something like Consul. So when the user makes that request, in particular in the Kubernetes world, everything is ephemeral. Things change dynamically. You want to know where to route that request to. And even at the service level, you need to know where to route to. Once you're kind of going upstream, you need to look at Consul. Where is this service located? And it can also be located, say, on other subnets, other VPCs, maybe on some colo infrastructure, these kind of things. So let's look a little bit more at the API gateway, because I see a lot of confusion around what we call north-south traffic. So excuse the kind of orientation of this graphic, but usually we call ingress traffic north-south. Imagine a diagram like this way, north-south coming into the system, whereas things like service meshes look at east-west, which is service to service. So focusing at the moment on north-south ingress traffic. Many words, API gateway, edge proxy, these kind of things. Fundamentally, the job of the edge proxy is to expose internal services transparently to end users. You don't want your user caring or knowing, ideally, what is on the back end serving the request. The API gateway should expose routes, or it should expose gRPC APIs, and the user simply, the client simply makes a call into that. In terms of security, it's a great place, obviously, to do TLS termination. But it's also things to think about. If you're actually on the edge, you need to do things like minimum protocol version. Because a common attack is to try and downgrade the TLS protocol. And 1.0 and 1.1 have known issues. 1.2 is kind of the gold standard, or 1.3 as well. But you need to think about these things. It's also a great place to do end user auth. Yeah, so we do a whole bunch of integrations in Ambassador with things like Otka, Auth0, Keycloak. There's many sort of IDPs out there that offer fantastic ways to authenticate users with social logins or with integrations into Active Directory, all this kind of good stuff. And they'll often give you a token back that you can propagate down through the stack. Now, you do need to make sure your apps are capable of propagating that back, that sort of down the stack, but you can apply scopes or roles after the authentication and do authorization at the service level based on that token. A key thing with security is it's not just about auth-n and auth-z. It's also about things like rate limiting. A very common attack is to kind of fuzz, APIs or just constantly hammer them, DDoS them, looking for memory leaks, looking for issues. So you want to rate limit maybe based on IP, based on country, a whole bunch of other things. This is very much part of your security at the edge. So I'm going to just walk through some open source stuff config with Ambassador, just to give you a sort of flavor of what I'm talking about. We use CRDs to do config. So Ambassador is Kubernetes native, sort of born of that era. And you literally just define some config in a CRD, in basically a Kubernetes resource. You can see we're specifying an API prefix there, /API. I'm actually using console as a resolver. So it will look to console, look for the service Emojify API sidecar proxy, and it will route the traffic, the ingress traffic to that service. Now, I'm actually using TLS there. I've got a secret with some integration, and that will look at console to get the TLS certificate and all the traffic going from the edge, from Ambassador, to the service. And we'll look at more how this works in a minute. But all of that traffic will be encrypted as well. Now, that's great for developers. The beauty of doing things like, say, Kubernetes mapping is each product team, each dev team can work on their own mappings, and they're not all working on one centralized config file. So they can all do their own prefix configuration, their own rate limiting, their own circuit breaking, a bunch of other timeouts, all that good stuff. But you can also centralize some things, for example, TLS. You want TLS termination to apply to all of the endpoints. If you're an operator in particular, you want to centralize sane defaults. You might want to have some global rate limiting policies that people can override if they want, but you want sane defaults to make sure the system is secure. This is a good place to do this kind of thing. You can see here I've got an example of how to always upgrade the protocol to HTTPS, and also it's just a Kubernetes secret with a certificate in, and that's the way we terminate TLS in Ambassador. One thing I would say is friends do not let friends manually generate TLS certs. I see this in big companies, I see this in small companies. I'm a massive fan of things like Vault, of course, but also Cert Manager. If you're in Kubernetes, this is a fantastic tool using the Acme protocol, using something like Let's Encrypt, something like Vault on the back end, and it will automate the renewal of TLS certificates. You should never have your users telling you that they're getting a warning in their browser and the padlock's failing because you've got an expired certificate. And to be honest, I've done this, so I'm a bit of a hypocrite up here. but as in, I would strongly recommend you do this kind of automation. Whatever you use, like say Vault, Cert Manager, a bunch of other great products out there. But this stuff is really, really important. We've got a bunch of integrations in Ambassador where you can use Cert Manager to automatically update your TLS certificates and so forth. References there for you as well. Quick aside, so I talked about this is all focused on end-to-end security, from user right the way through to service. And CDNs, or content delivery networks, are often in the mix. And some folks treat CDNs as like magical security wrapping. We put a CDN on it, boom, it's done. Be very careful with that stuff. I mean, I've used Akamai, Cloudflare, a bunch of things over the years. They're all really good, but you need to make sure you've got the security configured correctly. I'm not sure how big this is. Apologies if you can't read it, but I'll walk through it. But you need to make sure you have an origin certificate installed so that Cloudflare, say maybe terminating TLS at the edge, but you want to make sure the transport from the Cloudflare, from the CDN to your origin is also TLS. And Cloudflare makes it super easy to install an origin certificate on something like Ambassador and ensure that all traffic is encrypted. There's also things like HTS, I think it's HSTS, I always get that one wrong, for forcing, it's a new protocol or a new standard for forcing everything to be HTTPS on the website. It will not allow HTTP traffic. You can do automatic upgrades from HTTP to HTTPS as well, really quite important. And you can even do mutual auth with things like Cloudflare. So you can make sure that it's only Cloudflare talking to your origin. So kind of like mutual TLS as opposed to just TLS encryption. Very nice stuff. Now, like I mentioned, people do treat CDNs as kind of magical security wrapping, and it's a great paper I bumped into. I think this is courtesy of Johnny Christmas. If you're looking at like white hat hacking, Johnny Christmas has got some fantastic talks online. We interviewed him for InfoQ as well. And there's a whole bunch of academic research around how easy it is to bypass things like Cloudflare and other, they call them CSPs, cloud-based security providers. So this stuff is really important to think about. Make sure, even if you have got a CDN, that you hide your origin, you make sure all traffic going to the origin is encrypted, all this kind of good stuff. Moving on now to more consoles domain. And this is kind of the east-west traffic, the service-to-service traffic. I was super excited when I heard last year that console was moving into the service mesh space. It's a very popular topic. Istio has been generating a lot of buzz, but I think console, with the kind of second mover advantage of watching what's going on, and HashiCorp's fantastic, DAO of HashiCorp, the fantastic design principles, I'm really liking the console approach to service meshes. But I digress. First off, a service mesh is focused on exposing internal services to internal customers, internal consumers. Same deal, yeah. We should not really care where things are running in an ideal world. We should make a request to a identity, and that should work fine. I should say, I've got a web server, I make a request to the app tier makes a request to database. We should be able to just use those kind of principles and not worry too much about where these things are running. Yeah, we need to make sure obviously traffic is secured and the endpoints are secured, but the service mesh will hide sort of the location of the services. It's a great place. If you can guarantee, say, communication between a locally running proxy, and I'll talk about that more in a minute, but a service mesh is typically implemented with a sort of mesh of proxies. If you can guarantee the comms between your service and your proxy, so you're running everything on, say, a loopback adapter, that all communication is going via the proxy, and therefore you can put the identity using something like an X509 certificate from that proxy. So it's transparent to the app, but the proxy is basically, it gives an identity that console can manage. So web identity or database or app tier. Once you've got mTLS, once you've got identity, you can do TLS, so you can secure transport between all these services, which is great. You also want to look at things like access control lists. Who can do what on the console server? You don't want just anyone being able to sort of apply various say, intentions of who can speak to who. So you also want to look at those kind of things. Intentions are really interesting in and of themselves. Intentions literally allow us to use service identity to define what can speak to what. So web can speak to app tier can speak to database, but web can't speak to database, for example. Mitchell touched on this briefly this morning. The service mesh, because it's kind of everywhere and all the communication is going through it, it's a great way to do things like observability and also enforce metadata is being propagated down through the stack by the app. The service mesh, it doesn't come without a cost. Service meshes are quite expensive sometimes to operate. To be fair, I haven't had much experience with console yet because it's quite new, but we've worked with customers with Istio. Istio is great in terms of functionality, but it's operationally quite complex and quite resource heavy in some situations. They're doing a lot of great work to make that easier, but you have to bear this in mind. Another layer in the stack clearly adds complexity and clearly has resource overhead. But there's a lot of good things with it. So, exploring end-to-end comms. I mentioned about Envoy a few times. Are people generally familiar with Envoy as a proxy? Yeah, I see a few nods. Awesome. It's a great kind of cloud-native proxy, something like an Nginx and HA proxy I've been using for many years. Envoy was born out of Lyft, and it was born, like Matt Klein and the creators behind it have done a lot of work in Amazon and Lyft and other places. They really understood how to make the proxy kind of very relevant to the cloud. And I'm not saying these older proxies are bad, but they're born of an era, not of the cloud, and it can make configuring them and running them on cloud somewhat challenging sometimes. So the secret today is Ambassador, I mentioned before, open source project. It is basically a control plane onto Envoy. And it's customized for north-south. Yeah? So we literally take the config you write in the CRDs and Kubernetes, transform them into Envoy config, because Envoy config is quite hard to manually write. It's a nice JSON or YAML file, very understandable, but really hard to create, so you want to automatically generate them. And then same thing with Consul. Consul now can deploy a Envoy proxy next to all your services. Yeah, so in this case, I've got a bunch of services here. Consul will handle things like certificate generation and sending out certificates to each of the proxies. You can obviously use Vault and all that good stuff in the back end, but Consul is the one pushing out all the configuration to these proxies, the TLS certs and so forth, and all communication in the services is now going via the proxies. So again, if you're running something like on the loopback adapter on localhost, no traffic leaves the instance or the pod without going first through something like Envoy. And when that happens, we can do a bunch of interesting things in the proxy, such as apply various security things and also do observations and so forth. But Envoy is fantastic. So hat tip to Matt Klein and the Lyft team for creating this. And hat tip as well to the HashiCorp for integrating it so nicely into the console stack. So I'm not going to do lots of console config stuff because I'm going to assume most of you in the room probably are familiar with console. If not, the docs are fantastic anyway. But I do want to say I've been using it a bunch with Kubernetes of late. And I've said it once, but I'll say it again. The Helm chart install for console is awesome. I was playing around with 0.81 and 8.2 a few days ago, and it just works. Yeah, nice config, secure out of the box now. Real good stuff. Once you've deployed console into your Kubernetes cluster, it's literally like sort of 3 or 4 lines of config to wire a service in to Kubernetes, from Kubernetes into console. I'll make it a little bigger. You can see here we're literally wiring in the Envoy proxy to our service using that one line, connect inject. Yeah? There's a mutating webhook that is installed as part of the Helm install that will fire up an Envoy, do the configuration, the bootstrap configuration, run it in a Docker container next to your service. Providing you bind your application to the local host or the loopback adapter, and then make requests out via ports, such as you can define your upstreams. So anything we do, for example here, localhost port 8003, will go to the console service called Emojify Face Detect. Super easy to do the right thing. Yeah, we can very easily connect, put our proxy into the service, very easily specify the upstreams, and then we can just do localhost 8003 or localhost 8005, and Envoy and Consul will automatically handle not only all the routing associated with that, including the dynamic routing, but it will also do the identity and the TLS management as well. Great stuff. Anyone who's been to London will no doubt recognize this, yeah, but one thing I would say is mind the gap. There's a bunch of places in this from end user to service where you can accidentally forget to do encryption. Yeah? And I mentioned before, but I do see a bunch of folks encrypting at the CDN, so terminating TLS at the CDN, but then forgetting to encrypt the traffic from CDN through to origin. I see a bunch of folks say not running a CDN, but terminating TLS at the edge, and like that's the ops responsibility. But then the dev team are managing the service mesh or some other thing, and they're not securing that first initial hop. So from the edge, TLS terminates, hop to the first service, then TLS upstream is engaged, but that initial hop they've missed. And you definitely want to make sure that any hops internally or across the VMs are secured as well. Like mind the gaps is a nice reminder to really think about this stuff. Changing tack a little bit around identity and network segmentation. So I mentioned before that this Death Star model of security is potentially a bit dangerous. It's a good first start, but it's a bit dangerous. If you've got a service that is vulnerable to remote code execution, people can basically get in, get some kind of shell perhaps into the system. Now, depending on what kind of access they get, it can kind of be game over. If they can get root access on a box or a pod, and it's really hard to defend against some of these things, but we want to stop the opportunist. If they manage to get in some kind of access to your services, we want to limit the damage. Now, obviously, there's an infrastructure level here of sort of segmenting, and I'll cover that in just a second, but we also want to secure the services, secure traffic between the services. Dialing it back a second, if someone does manage to get in, say, to a vulnerable Java dependency or a vulnerable Node dependency, they can often start moving around the system. That's quite damaging. And they can lurk as well, and be very opportunistic in what they sort of find and what they steal effectively. We've dealt with this since networks were a thing, basically, by doing segmentation. You have front end and back end. Anyone who's done VPCs in Amazon, firewalls in Google, you'll recognize that they're sort of virtualized concepts of what used to be old racking and stacking and using routers and various things, using firewalls. In the kind of more modern microservice type world, we're often running all our back-end services on something like a Kubernetes or a Nomad. And we do still want to say that A can only talk to B and C and not D, but how do we do this? Particularly, and Mitchell mentioned this earlier on, actually, I was quite happy to see, within dynamic environments. So things are coming up, they're going down, IP addresses are changing on the pods in Kubernetes. All this stuff makes it really hard with the old kind of approach of using ports and IP addresses to lock things down. What you really want to move from here is kind of the IP rules to literally intentions like service A can talk to service B. And you also want to be able to identify components within the system. So we've got the Ambassador component here. This is say service A, service B, service C. We really need to be able to identify the actual components within the system to enable the intentions to say front end can only talk to web or only talk to app. Now, I showed you the console config earlier. The intentions part of console is super, super easy. You can do a kind of, on the CLI, console intentions create deny all, and that basically will stop all traffic in using console and Consul Connect. And then you can do console create allow and selectively allow sort of communications, something like a NACL, or if you're familiar with that kind of thing from Amazon, you can literally add in intentions on the top of the default deny and very securely define what can talk to what. Now, if you're a bit hipster, you can use something like service mesh interface. So the SMI, the new standard announced actually with Microsoft and HashiCorp and a bunch of other folks, Bryant from Linkerd, the Istio people as well, only a month ago at KubeCon. So it's brand new kind of thing, and Nick, hipster that he is, was basically telling me all this good stuff about SMI, and he's woven it into the demo as well, which is fantastic. And looking through, I was a little bit skeptical up front. The idea with the service mesh interface is to create a layer of abstraction over all the service meshes. You've got to be a bit careful with sort of lowest common denominator, but the idea is you can define certain config with the SMI. It doesn't matter whether you're running console, Linkerd, Istio, you define it in the SMI spec, and then it gets translated per your target. And console has got support for SMI. So rather than writing, say, the intentions manually or using the console API, we can actually now use a more Kubernetes native way of defining things. Yes, it's a little bit verbose, but it is quite new. I think the community really is looking for input from yourselves in particular on how to refine some of these ways of defining intentions and traffic rules, traffic policies. But for me, it makes a lot of sense. Having done a bunch of work in Amazon, in particular in AWS, I define my traffic target. It's a CRD within Kubernetes. It's an entity defined within Kubernetes. I specify a route that I'm working with. This is a simple TCP route, but you can also define HTTP routes with different prefixes, so metrics here, API here, for example. And then it's a default deny all. So you then just say, Ambassador, in this case, can talk to Emojify website. And it uses service accounts in Kubernetes, and Consul does some very clever stuff with mapping service accounts to service names, for example. So it's really nice, and we can put this, if we're using kind of the GitOps kind of approach, we can put all this config in our pipeline, test it, continually roll it out. It's much easier than trying to do CLI calls or something like that. Now, I was at this point going to do a demo, and this is totally, I'm not unfortunately, this is totally going to sound like the dog ate my homework, but I literally got stuck in New York at the weekend, where I cancelled flight via courtesy of Delta and Virgin Atlantic, and I also lost my bags as well, so I'm modeling the summer catalog from H&M just down the street. I had to go shopping last night, and when I looked at the demo, it was broken, and in my jet lag state, I just couldn't get it working. So I'm blaming my American friends, and if anyone saw President Trump's July the 4th address, I'm thinking that when they took all the airports in the late 18th century, might have something to do with my bags going missing. I don't know. But But the good news is that Nick has put up a fantastic GitHub repo with all the code we're going to demo. Emojify, it gives the actual app stack, it gives all the Terraform for setting stuff up, all the console config, SMI demos. Nick and I presented a very similar version at KubeCon, so our talk is online, and Nick even redid some of the demo stuff on and put it up on YouTube. And I promise by next week I'll do like updated demo. If you go into the Ambassador Pro reference architecture, there's an early Terraformed example with GCP using VMs and Kubernetes, which I'm working on. And yeah, I promise next week or maybe the week after, very soon, I will put that up and record that and share my content on that as well. So on that note, I shall sort of wrap up and say with a conclusion. Security is everyone's responsibility. I'll say it again, but it doesn't matter where you are, and you need to work together. I know we've got DevOps, I know we've got SRE, it's all great stuff, but I do see some organizations sort of just relabeling old departments as DevOps, relabeling them as SRE, and they're still not communicating. So we really need to make sure that security is everyone's responsibility. If you're trying to do code scanning, get it into your pipeline early. If you're trying to encrypt all your traffic, work together to make sure there are no gaps. I mentioned that, I think this app modernization trend is really good. We're bringing in more things. We are moving things like, Kubernetes, like Nomad, great stuff. But we have to be respectful that the infrastructure is quite heterogeneous. And that makes it quite challenging to do security well. So using things like Consul, I think, are a really nice way of applying a layer of abstraction over the top of a lot of these things. Defense in depth is vital. I've said it once, I'm going to say it again. You need to think about a whole bunch of things in terms of security, but even at the communication level, you need to think from CDN to edge to service to data store. You want to encrypt the whole gamut there. Do, again, mind the gaps. Very easy to forget or misconfigure things. Want to make sure security is enabled all down through the stack. And lastly, I've said it many times, but it's really, really important. I do think things like Consul in particular make it easy to do the right thing. I think that's part of the HashiCorp ethos in some ways. And security is even more important because we will bypass stuff that's hard to do. Need to perhaps think about the control planes for north, south, and east, west. I think they are subtly different, the requirements at the moment. Ambassador, like I say, focuses on north, south. Other tools do the same thing in that space. And Consul focuses very much on the east-west traffic, as does Istio, as do other things. But do recognize that security needs to be thought about through all those things. Some references for you there, links to the demo, links to some websites that I've referenced. There's a great Instruct, actually, a video created by Todd and a bunch of other folks. If you want to actually go and play with some of this stuff, like in the browser, you don't need to spin anything up. You can go and play in the browser. It's fantastic. Great way to learn Consul. Great way to learn a bunch of stuff from HashiCorp, actually, so definitely check that out. And there's the emoji app repo. I don't think I'll take questions now. I'm happy to hang around a bit at the end and take questions there. But I shall say thank you for your time.